Hello, everyone. My name is John, or at least that's what my driver license says, and welcome to a PowerPoint presentation on Docker. I know this is different from my usual content, but I'm sure you will still like it all the same. So let's get straight into it. So, actually, to start off with, I have a table of contents over what we will be covering in this PowerPoint. So, number one, what is Docker? Two, why is Docker important? Three, Docker architecture. Number four, what services use Docker? And then finally, we're going to end off with some case studies of the services that use Docker, such as Spotify and Google. So, what is Docker? Docker is a set of platform as a service products that deal with the deployment, development, and running of applications in a container. And containers are relatively lightweight and isolated environments that contain an application and all of its dependencies together. We will be discussing more about that later. It allows developers to create consistent and reproducible software environments, making it easier to build, test, and deploy applications across different systems. Docker's containerization technology has become a fundamental tool in modern software development, and as its kernel level access enables efficient resource utilization, scalability, and portability of applications, making it particularly valuable for DevOps and other cloud native workflows. So, why is Docker important in modern software development? Docker's containerization was a breakthrough in modern computing. Docker can package an application and its dependencies inside a virtual container that can run using one single operating system kernel, and therefore they use fewer resources than virtual machines. When running on Linux, Docker utilizes the resource isolation features of the Linux kernel to allow the containers to run within the single Linux instance, avoiding the overhead of starting and maintaining VMs. Docker on macOS and certain Windows container utilizes a Linux VM to run the containers. The ability to have a container run on a single OS instead of an instance means that a lot of containers can be ran parallel at the same time, which significantly reduces overhead. Actually, let's quickly go through Docker architecture. It first has a client, or how you send requests or commands, and a container, which we will talk more about on the next slide, but it's essentially the main feature of Docker. It's total application packages in a lightweight format, and basically start a show. An image, it just was how to create the containers. A registry, which stores the images that creates the containers. A daemon, which interprets client commands. And networking, which is how the containers and host all interact. So actually, I do have a GIF here of how you can see the client pushing commands to the daemon, and depending on the type of commands, it can go to the images into the container or the images into the registry, which is how it all works. I included a link to the Twitter post of who I ripped this GIF from, just in case anyone tries to crucify me about crediting the proper people. But he did make a pretty good video about it, which is also included in the Twitter post. I'll have that linked in the description and any other sources I've used to make this video. Moving on, we have the container. A Docker container is the instance of an image that can be created, started, moved, or deleted through a Docker API. Containers are a lightweight and independent method of running applications. They can be connected to one or more networks and create a new image depending on the current state. Being that they are a volatile Docker component, any application or data located within the container will be scrapped the moment the container is deleted or removed. Containers mostly and by default isolate each other and have defined resources. So I have an example here because I can explain better in written text and pictures than I can by speaking. But I have a picture of a containerized and also a traditional application running on a system. I want to draw attention to this traditional one first. A lot of you may be familiar with how a VM works or have experience working with a VM, but some of y'all don't. That's fine. I'll go ahead and explain it. You first have the infrastructure. In our case, it would be our laptops, PCs, or if you're special, you have servers that are running our Windows or Mac OS installs. But some of y'all are also special and running Linux on your daily driver. And then you have the hypervisor, which is something like VMware or VirtualBox, and that's how it communicates between the infrastructure and the VM. Then generally on our VMs, we would have a Linux install. Some of us have done a class where we had to do a Windows install as well. And then the application is running on that Linux install or the guest operating system, whichever one you made. And then this last part is called a VM. We would then duplicate this VM over and over for however many instances of a program we would need. So, for instance, a web server would be hosted on multiple VMs, and depending on the traffic needed to load balance it, we would keep on creating more and more VMs depending on the traffic that's coming in. You can tell this is awfully inefficient because you are duplicating an entire operating system and needing to allocate memory, storage, and processing power to the VM and other infrastructure like cooling and space. But and all this is just called overhead or the cost of running a service. For a day-to-day consumer like us, we don't really care about this stuff, but for major corporations, it can add up. So Docker was able to create a thing called a container. I consider it to be a breakthrough in modern computing as it was greatly reduces the overhead for running services. So let's take a look at this picture on the left. We have the infrastructure and host operating system, which would ideally you would have it on a Linux machine as that is what Docker is designed for. Then you have the Docker service running on top of the host operating system, and then the containers for the applications. And each container has everything it needs to run the applications. You don't need to create a whole new operating system every time you want to spin up a new service. So you would just spin up a new container, which is just significantly lighter than spinning up an entire new operating system. You can probably already tell that you could probably run a lot of applications and still use less infrastructure resource than it would take running one VM. Companies could use Docker and essentially increase their resource capacity without having to expand their infrastructure. The first component of Docker, which allows the user to communicate with Docker, is a command line interface utility that allows users to interact with the Docker daemon called the client. The Docker client communicates with the Docker daemon via the REST API. It is a client server architecture, and therefore Docker can connect to the host remotely and locally. Whenever a user issues a command to Docker, the client sends the desired command to the host. If there are multiple hosts, the client is also able to interact with multiple hosts. The Docker client can run on the same host as the Docker daemon, or it can run on a separate machine and communicate with the Docker daemon over the network. So, the daemon, this is the most essential component of Docker. It is as it is directly responsible for fulfilling the actions related to containers. It mainly runs on as a background process that manages parts like network, storage volumes, containers, and images when a container is prompted to start up due to Docker. The client translates it into a REST API call and returns it to the daemon. The daemon then communicates with the OS. The daemon will only respond to Docker API requests, and it can also interact with other Docker services, daemons. So the registry, it's there's not much to say about it. It's actually been moved over to distribution, and they call it distribution registry now instead of just registry. But Docker images require a location where they can be stored, and the registry is that location. Docker Hub is the default storage location of images that are stored in the public registry, and registries can also be private or public. So, networking. multiple types of networking that can be done. And so down the list, it'll be none. This driver will disable the entire networking system, hindering any container from connecting with other containers. Useful for, I guess you could say there would be useful for malware engineering where you don't want it to spread at all. Bridge is a default. It's for a container which is used when multiple containers communicate with the same Docker host. A host where there are instances where the user does not require isolation between a container and a host, and the host network driver is used in that case, eradicating this isolation. There are other ones, such as overlay. Overlay network driver allows communications between different swarm services when the containers run on different hosts. A MAC VLAN, which makes the network driver makes the container look like a physical driver by assigning a MAC address and routing the traffic between the containers through this MAC address. I don't really understand or know instances of where you would use these, so that's why I've put them separate, but I just wanted y'all to know they are still there. What services are using Docker in the real world? So I know many of you have used entertainment services such as Spotify and Netflix. They utilize Docker, and I'm sure some of you have utilized Uber and Lyft before, and some of you may have also subscribed or torrented Adobe products. They also use Docker. For the boring companies like IBM, Microsoft, GitHub, Google, and Cisco, they all use Docker in their daily workflows. So, fun company first. Let's talk about Spotify. Spotify, in particular, had their own version of a container orchestration system called Helios. However, it was not efficient to have them develop their own container system, and they decided to instead adopt something else that was supported by a much bigger community. They stated they wanted the added velocity and reduced costs and also align with the rest of the industry on best practices and tools. And the biggest success that they saw with migrating to K8s or Kubernetes is a service that is currently running on K8, handles 10 million requests per second. It benefits highly from auto scaling, which is the ability to automatically provision or deprovision new VMs on demand when network loads increase or decrease. By VMs, I do mean containers. Before, the migration teams would have to wait for an hour to create a new service and get a host to run it in production. With K8, they were able to get it up and another service up and running in a matter of minutes. While not explicitly said anywhere, it can likely be inferred that Google also benefits from auto scaling that is provided from Docker's containerization, as Google processes approximately 99,000 searches every second, or 8.5 billion searches per day. During influxes, it will be useful to spin up more instances of a service. Google also likely uses the containers for internal development, testing, and deployments. Docker containers are also used a lot in microservice architecture, where services are broken down into its smallest part to be able to pair and combine with other services. It's part of their mission to build scalable and modular system. Of course, there needs to be an effective way to manage all of this. Guys, that's the end of the video. I hope y'all enjoyed. I spent a lot of time working on it. If there's anything y'all need, it's probably in the description. If it's not in the description, you probably don't need it that much anyways. I'll see y'all next time, alright? Take care.